Hi, it's Miss House. Let's finish up section 1.6. In number 11, they ask us to use the transformation of the graph f of x equals x squared to determine the graph of the opposite of x plus 2 squared. All right, so let's talk first about f of x equals x squared. Now, in the video about the graphs of the basic functions, I talk about how this is a parabola, which is a U shape, and it goes through the origin. Okay, pretend like that goes through 0, 0 there. Okay, so it's a U shape on both sides, right? It's U, it's curvy, it's not straight like the absolute value, it's a curve. And we're asked to do the opposite, that's a negative, of x plus 2 squared. Now, we've got to think about order of operations, and we're going to do the inside change first. That's a horizontal shift. So it's going to be to the left 2, because remember that when the change is on the inside of the function, right, it's on the inside of the squaring function, right, because of those parentheses. You do the opposite. First of all, it's horizontal, and you do the opposite of what it looks like you would do. So instead of going to the right 2, you actually go to the left 2. Now, this negative, that should be equals a negative, like you see over here. That negative tells us we're changing the sign, not of the x, because if we wanted to change the sign of x, it would have to be in these parentheses. So we're changing the sign of y. And if you think about it, if y was up here and now it's down here, instead of at positive 8 up here, it's at negative 8 down here, you're reflecting it across the x-axis. So let's talk about how MyMathLab wants you to do this. Click anywhere on your graph and you'll see this keyboard down here, right? Or this palette down here. The parabola is the U shape, so we select the U shape. The next thing we do is we click anywhere on the graph and it gives us that basic shape right there at the origin, like I tried to draw. We also get this little palette here that has us do our transformation. So we know we need to go to the left 2. That's a horizontal minus 2. Now watch when I click, it picks it up and it moves it over for me to the left 2. And I need to reflect it across x, because remember, the change is not to the x. To be changed to the x, it's got to be right in front of the x. So it's outside the parentheses, so that's a change to y. So I'm going to reflect it over x. It's the opposite of which one you're changing, right? So we're not changing x, we're changing y, so we go over x. And that's what my graph would look like. All right, so let's take a look at our graph. I'm going to actually pop it out here. And think about what we did. We went to the left 2, and we were up like this, and then we reflected it upside down. So I save that, and I check my answer. Now, this one is also the graph of x squared. So it's that U shape again. So I click anywhere on the graph, get my palette, I hit the U shape, I click anywhere on the graph, and I get the basic graph. Okay, that way we don't have to draw it by hand. There it is. Now, this one has a lot of changes, so you have to follow order of operations. Start in the parentheses. That's left 2, horizontal 2. So minus 2 goes here. Now, this subtract 5, remember, please excuse my dear Aunt Sally, add and subtract are last. So the minus 5, that down 5 goes last. So we won't do that yet. We got to take care of this negative and this 3. Now, the negative will flip it, and the 3 will stretch it, because each y is going to be 3 times as high as it would have been on the original graph. So I've got to stretch it vertically by 3. There it goes. Look, it made it look skinnier. Think about a rubber band. You got a rubber band and you stretch it, it's going to look skinnier, right? Now I got to reflect it across x because I'm changing the sign of y. And now the last thing I do is go subtract 5. So I'm going to vertically go down 5. And there it goes. You can see it's gone to the left 2, stretched out and flipped over. And by the way, you can stretch and flip or flip and stretch because it really doesn't matter which one of those you do first. Okay, those kind of have equal priority. All right, so, and then we went down 5 because that's a subtraction. It goes last. So I'm going to check my answer. Got it right. You got to be careful. You got to go in order according to order of operations. All right, so this one is based off of the square root graph. So let's look at a quick review of the square root graph. Now, a square root graph, you cannot take the square root of a negative. So when you have the square root of x, your domain is from 0 to positive infinity. Okay, so there's going to be no graph over here on the original. Okay, we're on the inside. That's a horizontal, opposite of what we think. So -3 means we go to the right 3. So we look at our graph and we find the one that goes to the right 3. Now look, this one went down, C went up, this one, D, went to the left. It has to be graph B. Okay, so here we have another square root function, and we're going to do some transformations to that shape. You'll recall that the square root function, basic function, looks like that. Now I'm going to go over into Desmos to show you this one because it can be a little bit tricky and you got to really think about it. So here's Desmos. Let me clear these out. Okay. I'm going to start with f of x. Let me move this where you can see it. F of x equals the square root of x. All right, so there's that basic graph that I spoke about. Now notice that this problem has a reflection and a horizontal transformation. All right, so let's look at the Desmos. And let's put in f of x equals the square root. And let's do the x minus 6 first. I believe that was what it was. Let's look and see. Yeah, minus 6. Okay. So that moved it to the right 6, right? Now I'm going to change this to a negative x and look where it put the graph. It put it over here at -6. Now, you may think, well, wait a minute, that was supposed to go to the right 6 because it's a minus. Well, it did at first, but then it got reflected, so it ends up over here on this side. So the correct answer would be choice D. All right, here we have an absolute value. Now, we know that's a V shape, okay? But they don't really ask us to graph it. They just tell us to describe the kinds of shifts that are taking place. So we go inside here first. We do our horizontal. So that's a horizontal shift. There you are, horizontal shift. And then out here, that's a vertical shift. So that's all we're doing here, a horizontal shift, a vertical shift. Left 2, up 5. If we had to draw that V, it'd be very easy. Left 2, up 5. Okay, now they want us to actually graph it. So I click on the graph, I select the V, and I click anywhere on the graph. And look, it's not like the parabola, so you kind of got to get used to this grapher. It puts it wherever I clicked. So you got to be really careful when you're doing the V, you can't click and tell, you don't get that little box, dialog box that lets you move it left or right. You have to say that's left 2, up 5. So you got to count left 2, 1, 2, 3, 4, 5. And then you click and you go up 1 to the right 1 like that. Because remember, unless we stretch it or shrink it, either horizontally or vertically, it's just over 1, up 1, over 1, up 1, over 1, up 1. Check our answer. That's right. Now here we've got 3 things going on. We've got inside our grouping symbols, we have to do our horizontal shifts first. So that's to the right 2 horizontal. Okay. Then we do reflections or stretches in either order. And look, we got a negative on the outside. We're changing the sign of Y. Y is up here, Y is down here. That's across X. So that's going to be a reflection across X, right? And then the last thing we do is the vertical. So it's going to be a vertical shift down 1. Okay. Right. Now let's draw that graph. Again, this absolute value is not the same as the parabola. You've got to locate that little point of that V, that vertex, we call it, at the right spot. So we've got to go to the right 2 and down 1. So V is to the right 2. No, we got to reflect first. So let me draw this because we'll miss this if we don't. Let's get a clean board here. Let's think about what we have before we go too fast. Originally, it's here, and it's 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and over here it's negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4, like that. So it's up 1, over 1, up 1, over 1. We're going to go to the right 2, so 1, 2, do a different color. Same shape, same basic shape, okay? Now we've got to reflect it across the x-axis. So it's going to be down here. And now we have to go, let's look at the picture again. We have to go down 1, right? We got to go down 1. So instead of here at 2, 0, it's at 2, negative 1. So I click my V, I go to 2, negative 1, and look, I got to make sure I go, instead of up 1, right 1, I got to go down 1, right 1 to do my graph. And the last basic shapes of graphs we talked about were for the cube and the cube root. Okay, so let's do just a quick talk about that again. There's a whole video over these basic shapes. The cubic function looks like this. Okay, it is an odd function that when you flip it upside down, look, I haven't marked anything so you'll be able to see. Look, I'm going to rotate this guy 180 degrees. I'll go 90 first, and then I'm going to go 90 more. And look, it looks just like the original. I can't tell the difference, okay? So when we have this cubic, we do our transformations just like before. This one says go inside is a horizontal, so right 3. So this graph is going to be the same except, I'm sorry, right 7, to the right 7. So it's going to be over here at 7. Oh, that's a horrible graph. Let me redo that. Over here at 7, like that. Okay, so we click on the graph, and look, here's our little cubic thing. Now, the first time you do this, you have to experiment. Look, I clicked anywhere, and it's like the quadratic. It puts it there. We don't have to worry about putting the vertex. It's going to put it for us. And then we've got to go horizontally to the right 7. So horizontal shift, and look, this time they don't let us put the number in. They make us actually just do it manually. Okay? You got to get used to these problems just by trying them and then checking them. Okay, so now they've given us a cubic with lots of stuff going on here, okay? We always start inside. That's going to be our horizontal. So we do our horizontals first always. That is to the left 6, okay? To the left 6. We're going to go left 6 with our cubic. Then we're going to make it 1/4 as tall. So we move it left first. We don't change the shape, but then we squish it down by 1/4, by 1/4, and then we shift the whole thing down by 7. All right, we're going to pick some points this time on this one. Let's start with the original cubic function. Okay, that's f of x equals x cubed. So I'm going to pick a couple of negatives, a 0, and a couple of positives. -8, -1, 0, 1, and 8. And I got each of those by taking that x value and raising it to the 3rd power. All right, so that's why the graph looks like this. All right, so I'm up here, 2, 8, and then I'm all the way down here at 1, 1, and then -1, 1, and -2, -8. It looks like that. Now, I've got to go to the left 6. That's changing all of the x's by 6. Okay, so I'm going to change all of my x values. So here's my new chart. I'm not changing my y's. I'm just changing my x's. Okay, all the x's are going down by 6. So -2 minus 6 is -8. Then it's -2 minus 6. -1 minus 6 is -7. This one's going to be at -6. This one's going to be at 1 minus 6 is -5. And 2 minus 6 is -4. All right, let's plot those and see what they look like. So -6, 0 is now our new, like our origin. Our origin was over here, but the whole thing moved over, right? Okay. -5, 1 is up here. Let me do this. Let me do it a little bit clearer. Hold on one second. Originally, remember, it was over here, right? Like this. And now we're over here at -6, 0, and -5, 1, and -4, 8. So it's the same shape. It's just moved over to the left 6. Now the tougher part. I've got to make each of the y's 1/4 as tall, because it says 1/4 of these things. So the next thing I'm going to do, all I've done is the +6. Now I'm going to do the 1/4. Okay, now I'm not changing x's this time. I'm changing y's. So x's are going to stay. They've all been shifted 6 to the left. And now I'm going to multiply all of these by 1/4. So that's going to be -2, -1/4. That one's going to stay at 0. That one's going to be 1/4. And that one's going to be +2, because I multiply -8 times 1/4. -7 times 1/4. I'm sorry. Yeah, -1, not -7, -1, because we're doing the y's only, right? So -8, this -8 times 1/4, this -1 times 1/4, this 0 times 1/4, this 1 times 1/4, this 8 times 1/4. What does that look like? Well, let's take a look at that graph. Okay, so the -6 stayed here. Okay, -6, 0 stayed here. But instead of being at -8, what was it originally? It was at -8, -2. No, -8, -8, which is over here. Look, 6, 7, 8. Instead of being way down here at -8, it's now up here at -2. So what it does is it makes the graph look fatter. Think about this. We have taken something that's this tall and we made it this tall. So that's called a shrink or a compression, a vertical compression or shrink. Okay. And then the last thing we got to do is shift that whole thing down by 7. So the whole thing down by 7. So let's see. If we move these down by 7, that's changing the y's down by 7. So I've got to subtract a 7 from all of these. Okay. And I'm going to do the ones that are a little bit, arithmetic's easier to do. So let's just focus on these 3 points. Let's focus on that one, and that one. So that's going to be -8 and -9, -6 and -7 and -4, -5. Okay, so keep those points in mind. I'm going to click on the graph and pick this. Now, I believe, let's see if we, yeah. So here it's just going to let us do it by the chart. And again, you don't know until you click on the graph which method it is. But we know that we've got to shrink it vertically by 1/4. Okay. We know we have no horizontal stretching. That's multiplying on the inside of parentheses. We know that we went to the left 6 and we went down 7. And we have no negative, so we don't have any reflections. So this is what our graph looks like. And so let's check those points we said. -8, -9, okay? So let's see, -8, -9, there it is right there, okay? We said -6, -7. So -6, -7 right there, right? And then that last one we said -4, -5. -4, -5 is right there. So that's our final answer. Okay, so we have this last type, and it's the cube root. So we go down here, get us a new board, and remind you that the cube root, the basic cube root, also covered in that basic graphs, looks like this. 0, like that. Kind of looks like the cube, but it's on its side and it's upper. This is positive because when you put a positive in a cube root, you get a positive. When you put a negative in a cube root, you get a negative. Like the cube root of -8 is -2. That's why it's down here, like -8, -2. So all we have to do is take that graph and shift it, because this is inside, to the right 5. So this whole thing is just going to go over here to 5. It's going to look exactly the same, except it's going to be at 5. So let's see. It's got to be this one. It's the only one that's going through the 5. So that's going to be our answer. Okay, so this one is also a little tricky because you've got that reflection inside of a grouping symbol. So we're going to go out to Desmos and take a look and go slowly and see what happens here. So instead of the square root, I've got to enter a cube root. So let me find my cube root. And here's the cube root of x. Okay, this is what the original basic graph looks like. Now, I want to do the opposite of x, a reflection of x, and -4. So let's see. Let's do the horizontal shift first, because we'll always go horizontal, reflect, and stretch or shrink, okay, and then vertical, okay. So the horizontal, is the -4 part. Now look, it's over here now. So it's gone to the right. Now when we reflect by changing the sign of x, that 40 is going to go over here to -40. And this 6, whatever that is, close to 1 is going to go over here to this -6 close to 1. So I'm going to sneak a little negative in there. Oops, let's do a cube root. There it is. So there's the 40, okay? And that 40 is going to go over here to -40. Okay, now I'm going to change that minus sign and see how it reflected it over here. Okay, so we went to the right 4, and then we reflected across the y-axis. So let's see. We went to the right 4, then we reflected. It's going to have to be graph D. Let me make that big so you can see it. See that? To the right 4 and then reflect it across.